In this video, we are going to look at linear kinematics. We are going to continue to restrict ourselves to only looking in one dimension, but now we're going to go in two directions. Before, we were only concerned with moving forward. Now we might be moving forward and then moving back, or we might move forward, turn around, and move in the opposite direction. So let's get to it. We always have to start by establishing our frame of reference. Remember, the frame of reference is going to have an origin. The origin is where your frame of reference starts. From your origin, we are going to have an orientation. That orientation usually coincides with a spatial dimension. For the purposes of this class, we usually say the x direction is going to be the horizontal direction, and the y is going to be the vertical. Next, we also have to consider sense. Moving from, say, left to right would be one sense, while moving from right to left would be the opposite sense. Moving from a downward position to an upward position would be one sense, while moving from up to down would be another sense. So when we put those two things together, the orientation and the sense, we have our directions. So let's go back to our horizontal dimension. In our horizontal dimension, we can say that if we are moving forward, or as depicted on the screen here, if we are moving from left to right, that would be the positive direction. Now, if we went from right to left, that would be the opposite, or the negative x direction. It's still x because it's still the x dimension, just one direction happens to be positive, the other one happens to be negative. We can also say the same thing if we're moving vertically. Now, typically, we will say the upward direction is the positive direction, and the downward direction ends up being the negative direction. It doesn't have to be that way, it's just usually that way by convention. If you choose, you can decide that you want to make the y direction the horizontal direction. You can choose that you want to make going from right to left the positive x direction, or even the positive y direction for that matter. What's important is that once you've established your frame of reference, you don't change it throughout your analysis. Because if you do, you're going to get some really funky numbers, and it's going to be almost impossible to interpret. Okay, so I hope we got that down. We have our origin, and now we're just going to extend it infinitely far in both directions in the same orientation. One of those directions we are going to call the positive, and the other one we're going to call the negative. So now recall that position is your location within your frame of reference. Here we have two bodies, body A and body B. Body A is located to the right of our origin, and body B is located to the left of the origin. Both of them happen to be 10 meters away from the origin. Because we established that going from left to right is the positive direction, we'll say position A is plus 10 meters from the origin. And if we were drawing a position vector from the origin to position A, that arrow would be going from left to right. Now body B is located 10 meters to the left of the origin. Because we've established to the left is our negative direction, then that means that it's going to be negative 10 meters away from the origin. And again, we draw our position vector from the origin along the axis to position B. In this case, it would be a left pointing arrow. Now it's important to realize that negative 10 is not any less than positive 10. It's just 10 in the opposite direction. So when we talk about vectors, it's not like your bank account where a positive $10 means something completely different than a negative $10. Here, the value is the same, positive or negative. It just means which spatial direction we're talking about when we talk about positive or negative. So next, we can talk about displacement. Displacement, remember, is a change in position. So now, again, we are going to travel along our x-axis. And let's say we start at our origin, and we move from left to right, and we move to position A, which is now 10 meters away from the origin. Now we have a displacement vector rather than a position vector, and again, it's going to point from left to right. Now, if our body travels from right to left to position B, again, that's still going to be 10 meters away, but now that's 10 meters away. That's a negative 10 meters for a displacement. and position B and displacement for B is a left-pointing vector. Now, we can have several different scenarios about positive or negative displacements. In scenario A, we have a position that is going to be a negative position because it is to the left of our origin. Now, at some other time, P prime, we have a new position which is further negative than our previous position. Therefore, our displacement ends up being negative, and we went from being less negative to being more negative. Now, in scenario B, we are going to start in a positive position. And at some other point in time, P prime, we've moved further in the positive direction. Therefore, our displacement ends up being positive, and we went from being less positive to being more positive. In our third scenario, we start in a negative position, and at some time, P prime, we end up being less negative. We still have a negative final position, but we're less negative. But because we moved from left to right, even though we are still with a final negative position, that displacement was positive. Similarly, if I start in a positive position and then I end up less positive, I've moved from right to left. So even though my final position is still positive, I have a negative displacement. So a positive displacement can still end up in a negative final position. And so if you start more negative and you end less negative, but you're still in a negative final position, the fact that you moved from left to right in our frame of reference means you've had a positive displacement. Now, let's take a scenario that I think is very familiar to most of you. We are going to take a cup, and let's say that cup is currently at arm's reach, and we're going to bring that cup over to our mouth in order to take a drink. So we've established that that cup moved from left to right. It moved from our origin to our mouth by a length equal to L. Now, because we moved from left to right, we've had a positive displacement. Now, after I've taken a sip of my tasty beverage, I'm going to move the cup back at arm's length. So now I move the cup from right to left. So now the cup went from my mouth back to the origin, so it had a negative displacement. In this case, that negative displacement was the negative length of my arm. Similarly, we can think about what happens in the vertical direction. Let's say that I'm performing a squat or a bench press, and I start with my barbell in the upward position. I lower that barbell down to the bottom. I've now had a displacement that was in the negative y direction. Now I'm going to take that barbell in the bottom position and I'm going to bring it back up to the top position. So now I've had a positive displacement in the y direction. Now, it's important to recall that velocity and displacement will always be in the same direction, and that will always be in the direction of travel. So if you have a positive displacement, you're moving in the positive direction, and you're going to have a positive velocity. If you're moving in the negative direction, you're going to have a negative displacement, and you're going to have a negative velocity. But the acceleration does not need to be the same sign as the direction of travel. So let's take a case where we're going to move that barbell from the top position to the bottom position, or the bottom position back up to the top position. Here we can say as we move from the top position to the bottom, we have a negative displacement and a negative velocity. And as we move from that bottom position back up to the top position, we are going to have a positive velocity with a positive displacement. Now I'm going to be asking you to draw for part of class what the position, velocity, and acceleration profiles would look like for this particular activity. But let's return back to taking a drink. So again, we have that cup at arm's length, and we're going to bring that cup back to our mouth. So we said that first, because that cup was moving from left to right, in our frame of reference, that was a positive displacement, and the magnitude of that displacement was the length of the arm. And then we move that cup back as we go from our mouth back to our origin. So we said again that was going to be a negative displacement as we move the cup from our mouth back to the origin. So now if we look at the velocity and the acceleration here, we will see as that cup moved from left to right, our velocity was going to be in that positive direction, which you can see up at the very top. Now initially we sped up, and we sped up in the positive direction. So that means we had to have an acceleration that was also positive. If we're speeding up, the acceleration has to be in the same direction as the velocity. Then we are going to hit our peak velocity somewhere along the midpoint, which we're going to call here point C, at which point in time I have to start slowing down because that cup has to come down to 0 when it gets to our mouth. So that means that the acceleration has to be going opposite of the direction of travel. It has to be going opposite of the velocity vector in order to slow that velocity vector down. Okay, if the acceleration is going in the direction of the velocity vector, velocity is speeding up. If the acceleration is going opposite of the velocity vector, that velocity vector is going to be slowing down. And that's what we want until it gets to 0 where it touches our mouth. Now, if you look at the bottom set of vectors, it explains what happens when the cup is going from the mouth back to our origin. Initially, we're speeding up, but we're speeding up in the negative direction. Okay, our velocity is going to be in the negative direction, and if we're speeding up, the acceleration has to be in the same direction as that velocity vector, so that acceleration vector is also going to be negative until we hit our peak velocity. Once we've hit our peak velocity, we have to start slowing down so that the cup is going to have a 0 velocity when it gets to arm's length. So again, here the acceleration vector is going to have to be negative. It has to be opposite of the direction of travel. It's actually going to be a positive acceleration. So let's repeat that again. So now I'm going to take the cup from my mouth and bring it back to the origin. First, I have to speed up. So I have to have the cup going in the negative direction. So I'm going to have a negative velocity. Now I'm speeding up. If I'm speeding up, I have to have an acceleration that is in the direction of the velocity vector. So that acceleration vector is going to be negative. It's pointing from right to left. Then I'm going to hit a peak velocity, at which point in time I have to start slowing down. I have to be slowing down in order for that cup to hit 0 velocity when it gets to my arm's length. That means I have to have an acceleration vector which is opposite of the direction of travel, which in this case happens to be a positive direction. So you can see here, if we take the whole picture together, if I'm speeding up in the positive direction, or if I'm slowing down in the negative direction, I'm going to have a positive acceleration. Whereas in slowing down in the positive direction, or if I'm speeding up in the negative direction, I have to have a negative acceleration. So if a body speeds up in the positive direction or slows down in a negative direction, the acceleration is going to be positive. If a body slows down in a positive direction or it speeds up in a negative direction, then the acceleration is going to be negative. All right, let's take a look at some practical applications. I'm going to ask you to do in class a sketch. And I'm going to ask you to sketch the position, velocity, and acceleration curves for a squat with a pause at the bottom of the movement. All right, now let's take a look at the Pro Agility Test. For those of you who are not familiar with the Pro Agility Test, let's take a quick look at it. So the Pro Agility Test, you're going to start running 5 meters to one direction, then 10 meters to the other direction, and then 5 meters back to the start. So again, at the start, you go 5 meters in one direction, 10 meters in the opposite direction, and then 5 meters back to the start. Now you're probably going to be running in a straight line, but just so we can see how the different arrows are pointing, I just offset our positions a little bit. So you'd be starting in position A, you would run to position B, turn around, run all the way over to position C, and then run back to position D. So in class, I'm going to ask you to determine what the velocities and the accelerations are from A to B, B to C, and then C to D. And I'll finish by saying that the ability to decelerate is often more important than the ability to accelerate. And we'll discuss that in a little bit more detail in class.